And before that, we have seen the HDFS and what is MapReduce and why we went for Spark. All these things we have seen in the previous sessions. So any big data, the main idea behind any big data is write once and read multiple times. That is what the concept of big data. And in master node, we are storing metadata, and in data nodes, we are storing distributed files or blocks of blocks, right? So this is the MapReduce. And these are the Spark applications. The Spark is nothing but it is an in-memory processing engine, in-memory processor distributed engine, right? So we are working everything in memory. So whatever we are doing, the operations and all, and making it in the in-memory. That's why Spark is 100% faster than remaining technologies. The difference between Hadoop, MapReduce, and Spark is data is storing on the disk, data is storing in the in-memory, and everything is done in the disk, and here everything is in memory. There we are using replication to get the high availability of the data. Here we are using RDD, and these are the main. This one Spark is a little bit costlier than Hadoop MapReduce. And this is for batch processing. It will support all streaming and batch. That is what the difference between Hadoop MapReduce and Spark. And now see the components of Spark architecture, what we are having in this. Okay, so we are having here Spark SQL. We are using SQL in the Spark as well as data frames. Data frames is nothing but PySpark. So Python on the top of Spark. PySpark streaming data also can be taken in this. And ML means machine learning. Spark is also used for the machine learning, and Spark is also used for the graphics computation. Okay, so we are having Spark Core API. What we are having? We are having 5 kinds of languages: R, SQL, Python, Scala, Java. We are seeing only 4 in the Databricks, or in Databricks we are seeing R, SQL, Python, Scala. But backend we are using Java virtual machines. So everything would be on the Java. So whatever you write, everything will be converted into Java. So backend is the Java, and the front-end application we are writing R language, SQL language, Python language, and Scala. So you can see different kinds of sources here. The source may be database, any streaming applications, okay, data streaming applications, any other data sources. So what we are having database, any database. So the input may be any database, and maybe any streaming applications, data streaming, or any other data sources we can use, right? So what we are doing, we are seeing the ETL application of Databricks. So we are not seeing any other application. Here we are seeing the ETL application. So what is nothing but ETL? We have discussed many times. Okay, what is nothing? Extract, transform, and load. It is very important to remember ETL, because we are most of the projects without ETL, there will be no project for that. So we need to understand what is exactly ETL. ETL is nothing but extract, transform, and load. This is what the experience. Extract, transform, and load. So we are having raw tables, query tables, summary tables. So finally, we first we receive the data here, and then what we are making that for the, we are making to get ready for the curation, and then finally summary tables means which you are giving the data to any analysis, like any analytical platforms. Maybe either it may be OLTP or OLAB queries or reporting and dashboards. This is what. This is the Spark architecture. What we are having in Spark. This is a Spark architecture. So Spark architecture is having one driver program. That is nothing but Spark context. Okay. And we are having worker nodes. So in the worker nodes, we are having executor. Inside the executor, what you are having? Tasks. And we are having one catch. So this executor is having Java virtual machines. Executor is having the Java virtual machines. In catch, you are storing the memory there. Whatever the, right, cache memory will store the recent transactions, what you have done. That is the cache memory. And we are having Java virtual machines, JVMs. And who will maintain all these worker nodes? From the master node, cluster manager. Here in Databricks, the cluster manager is standalone. So, standalone. So let me tell you what is exactly ETL. We are having various sources. And after that, what we need one temporary storage or staging area. And finally, we are having one target. We are having one target. Okay. So sources we are having any like Salesforce, mainframes, any on-prem systems, everything would be the source. Source. Okay. Sources to what we are doing from source to staging or temporary storage. Staging or temporary storage. Staging or temporary storage. And finally, we are having one target. This diagram you should remember. Whenever anybody is saying ETL, you need to remember this line. Okay. So what I'm doing is I'm connecting and collecting of data from source to staging area. I'm connecting and collecting here. Source to staging area. Connect and collect. Connect and collecting the data from source to staging area. So for that, how you will write in the Spark is taking. You will write this. If you are using Spark as ETL tool, okay, df equals to, this is a data frame. We can understand, but I'm just giving the example. df equals to spark dot read dot API. What is this API? API is nothing but, maybe I can give you an example. Spark dot read dot CSV or spark.read dot any kind of data format you are taking. Okay, any API you are taking. So spark.read.api, if you take like this, then it is going to take from source to staging area. The data is moved. Okay. So this is what the connect and collecting the data. So what we are doing here in the staging area, we are doing data validations, data validations, and applying the business rules. Applying the business rules. Next step. In the next step, what we are doing, we are saving the data, saving the valid data into the targets. That is nothing but loading. We are saving the valid data after doing all the validations and all. Saving the valid data into target. This is nothing but what? This is nothing but loading. We are loading into the target. So to do that also, we need to write spark that write dot. This is a format you just need to remember. Don't worry. So how many types of ETL servers we are having? Many ETL servers we are having. I'll give you some examples. Okay, if you know. ETL server. Okay, what are the ETL servers we are having? Informatica, data stage, ODI. These are some of the examples. Okay, Spark server. Of the ETL servers. So for any, if it is like whenever you are using Spark, you need to get from different sources. But only thing when you are working with the community edition, the only difference is here you are connecting to the different sources in real time. But in community edition, what we are doing is in community edition, instead of source, instead of source, we need to upload, we need to upload manually. That is only the difference. Remaining everything is same. Same in real time and here also. Whatever we are doing, both are same. Here what we are doing is we are uploading data manually. Here you are collecting the data. This part, what we are doing is here we are manually uploading. In real time, we will connect this to different sources. Okay. And one more thing you need to understand. Source and target. Source and target. Both would be the same in community edition. Source and target both are same in community edition. Community edition. That is only the difference. And what we have seen yesterday, file system, not yesterday, before yesterday, what we have seen, file system commands. What are the percentage FSLS? So this is for Linux. Okay. Here how we are writing db tools.fs.ls, right? So percentage FSLS. which lists the data, what we are having. Okay. LS is for the listing files. Listing files, CP, copying, MV, move, MK, DIRS, creating directory, HEAD, head for read, PUT, put for placing a file or creating a file, RM, remove,
File.
RM, R for removing a non-empty directory. So what you need to understand, these are file system commands. These systems can be used in any file system. File system is nothing but what? Big data, where we are using the files instead of blocks. So here we will use the object storage, and in RDBMS we will use the block storage. This much we know, right? So this is a file system commands. Now we will see. And one more thing in the file system you need to remember, that is in Databricks, dbutils dot fs dot mount. This mount, wherever you see the mount, MOUNT, mount. Mount is nothing but we are using this for the logical path to give the path to that. Okay. Mounting is nothing but giving the path to store the data into that particular location. Mounting is nothing but giving the path to store the data into the logical path. So what we are having? We are having ETL process. In the ETL process, we are storing the data into the target from the source by taking one temporary storage area. In the temporary storage area, we are doing all the data validations and applying the business rules. So I'm just explaining you. So this is the Spark. Spark architecture can't be understood in one single session. It will take 4 to 5 sessions. While working, we will see into the Spark behavior, how it is behaving. But now what we are understanding is how the components are there in the Spark and what we are doing with them. What is the Spark architecture components? Okay. So this is the notebook. This is the notebook. Client, or you can say it is notebook, because notebook also would be the source. Okay, notebook. Inside that, what we are having is Spark Core, which is Core API. Spark Core API, which is also nothing but master node, or you can call this as driver node, who drives the worker nodes or slave nodes. Here we are having master node or driver node. Remaining is, I'm just taking 3, there would be multiple nodes. We are having, I'm taking 3 worker nodes. Okay, slots you have inside it. Slots. Every worker node is having 2 slots. Worker node. All these are worker nodes. First one, second one. Total 3 worker nodes here I'm giving. And from client to, I'm just drawing. So this marker node is, sorry, master node is connected to the slave nodes. It looks similar to the HDFS architecture, but there is some difference in this. Okay, so we are connecting this to client is connected to your Spark. Inside the Spark, what you are having? You are having Spark master node and Spark worker nodes. Okay. So what happens whenever in SQL context, if you remember, sorry, in SQL DB, what when I explained, if you remember, there would be two things: Spark session and Spark context. Spark session and Spark context. So whenever this client is connected to the Spark, what happens? One Spark session would be established. Spark session. Spark session is nothing but authentication. Authentication. Whenever we connected client to Spark, the Spark will generate one authentication. Authentication is nothing but one Spark session would be established. Spark session is nothing but which is the authentication. Okay, now I have connected with you, so you can send your queries to me, or you can send your data to me. That is what it is saying Spark to the client. Okay. Once after Spark session is Spark authentication or Spark session is established, then Spark context would be connected to your Spark. So this is Spark context. So what Spark context is doing? If you remember, I have explained the SQL DB. So Spark context will send the code, send the, which means it will convert the code into white code. White code is nothing but system understandable code. So what will happen whenever you start working with the Spark? One Spark session will be created. So it will give you the permission to send the data, which is nothing but authentication. So once the Spark is authenticated, the client and Spark context will be generated. Context is nothing but which you are able to send the code to the Spark. This code is converted into white code, which means it is in the understandable. So here one quick thing you need to understand. So whenever you have given that to master drive, a particular piece of code, that code to drive, okay, that is nothing but job. Okay, you are giving code to the master node, right? Code or data. So that code, particular code is nothing but whatever you are giving that, that is nothing but at master node. You are having job. Job is nothing but code. So what happens internally? This code is divided into stages. Divided into stages. Again, this stages will divide it into stages will send to worker nodes, worker nodes as tasks. This thing is very important. Okay, you need to understand this. So I'm having a piece of code, which is nothing but job. I'm having a piece of code. Job. Piece of code. Where I'm having this job, I'm having everything at master node. Now, what master node is doing? Master node is doing this job piece of code will be converted into stages. Next, stages to how many number of stages? And as many as connected into stages. Okay, these are all stages. Now, this stages, each stage is converted into tasks. Okay, each stage is converted into number of tasks. Each stage is converted into number of tasks. Job is divided into stages. Each stage is divided into number of tasks. So like this, each stage is divided into number of is all what all these? All these are tasks. Now, this task is given to who? This task is given to worker node. Who are dividing or who is doing all this work? This work is done by master node. Done by master node. Master node job. Okay. And these tasks are given to individual worker nodes. These tasks are given to the worker nodes. So now tell me, this is yellow color is the master node, and this one violet is we are having the worker nodes. In between, one person would be there. Who is he? Who will know that which worker node is available, which worker node is dead, which worker node is able to work and he is free. Who will do that? It is done by resource manager. This is very important. For Databricks, who is the resource manager? Databricks. Standalone. This is what the brief introduction about your what Spark. Okay. So what master node is doing? Master node is taking piece of code and it is dividing it into stages to tasks. Each task is assigned to one drive node. What driver? Sorry, one worker node. What worker node is having? Which is worker node is having two slots. Two slots. So it can run two slots is nothing but okay. Slots is nothing but available CPUs. Available CPUs. Available CPUs. So how many CPUs we are having in each worker node? Two CPUs we are having. It means it can run two tasks at a time. Each worker node can run two tasks at a time. So one CPU is nothing but one virtual CPU. It is not a system CPU, virtual CPU. So one virtual CPU is nothing but where we are working on the cloud. So cloud on the cloud, anything you can say virtual. So one CPU equals to one virtual CPU, which is nothing but on cloud. One CPU is nothing but one virtual CPU. So one CPU, one process. One CPU, one process. So each CPU will take one process. But remember, in your system, you are having CPU, right? That is, that CPU, one CPU can take two processes. But one virtual CPU will take only one process. But in our system, whatever the CPU we are having, original CPU, that will take two processes at a time. So one CPU will take one process at a time. Okay, so you need to understand. See here, what we are having, CPU, memory, disk, network. This is my system CPU. Okay. So in system CPU, one CPU will take, one CPU will take four processes. Okay, here I'm having the CPU, right? This CPU will take four processes at a time. Four processes at a time. But in general, in community edition or in any cloud, you are having one virtual CPU. One virtual CPU means one process. Suppose if I'm having two cores in my laptop, what it means? 8 processes. Each core will take 4 processes. Okay, you know, right? How many cores you are having? That many 4 processes it will take. So two CPUs, 8 processes, one CPU, 4 processes. It is like that. But in virtual CPU, one means one only. It can take only one process at a time. So whatever you are seeing in your cloud, anywhere you are having compute, right? Even in the cloud, you are having the compute. Even in your system, you are having the compute. Compute is nothing but what we have discussed. Compute is nothing but processor, CPU, memory,
RAM.
and network. So you can see here, this is my compute area. So in this compute area, what I'm having CPU, memory, disk. Disk is nothing but what I'm having my permanent memory in my laptop. That is ROM. Here I'm having memory. This is RAM in memory. You can see most of the process it is taking in memory, 87%, whereas disk 0. So if I'm transferring data disk to disk, means here I'm having some disk in my system, hard disk, that to any pen drive, it will take time. But in memory is very fast, right? If I want to copy one file from my CPU, from my C drive to desktop, it will take fraction of seconds. But the same file into another pen drive, it will take much time. That is what the disk to disk. And here we are having in memory. So any compute, what you can say, CPU, which is nothing but processor, memory, in memory plus disk, both are memory only. Memory and network. This is a compute. This is the compute. So community edition is having two CPUs. Okay. So any virtual CPU, one virtual CPU equal, you just remember blindly like this, one virtual CPU equals to one processor. Okay. This is all about this thing. So you are having two slots here, two slots. Two slots is nothing but it can run two tasks at a time. Two tasks at a time. So one virtual CPU, one process. This is what about worker node, and this is the driver node. And it when you are going with the Spark architecture, it is you are having DAG and so many things, but this is the just a model which you are having in your system that you need to understand with the Spark. Okay. So in database, how we are storing our data? In database, how we will be storing our data? In tables. Am I right? In database. I'm storing my data in tables. How you will store your data in Spark? So that is what we need to understand. These are the databases. So in this databases, I'm storing the data in the form of tables. System tables, file tables, external tables. Okay. I'm storing the data in tables. Okay, here is nothing. Let me open that. These are the tables. Customer, fact, location, and product. So you are storing data in the tables. But when you are working with Spark, how you will store the data? That is important. Let me display one table for you. So I'm having table. Class would be continued till 7:10 because I came 10 minutes late. So today You need to understand in database, we will store data in tables, which is object or data set. Then how we will store data in? This is very important question in interviews also. So how we will store data in Spark? Spark supports different data storage objects. Data storage objects. Here the data storage object in database is table. Okay, data storage object in database is table. So Spark supports different data storage objects. This is also called as data sets. Data sets. So you never call in your real time file. It is a file. We are receiving a file. It is not like that. We will call that as data set. Okay, data set is nothing but where you are giving your data. Okay, Spark supports different kinds of storage. One is RDD. One is RDD. RDD, which can support all languages, R, Python, Scala, Java. Okay, RDD can be supported by R, Python, Scala, Java. Okay, which is used till 2011. 2011. Okay, so it is invented in 2011 and it is used only for log files. If you remember, we have started the big data because of the Google and Yahoo. Google and Yahoo is having very large log files. Due to that, they want to migrate that to by using the MapReduce. They have done all this work. So here we are used. It is invented in 2011. RDD. Okay. So what is RDD and all? We'll discuss it. And second one is data frame. Data frame. So data frame also can be supported by all languages. R, Python, Scala, Java, which is invented in 2013. Third data set is data set. Okay, data set. Data set only Java and Scala. Java and Scala. So this data set we are not using because we are working with Python. We are working with Python. So we will use only data frames. Okay. Data set we are not using. This is compile language, which is invented in 2015. This is invented for compile language in 2015. So 99.9%, 99.9%. 99.9% usage would be on data frame. So our work completely would be on data. So data frame is very important for us. Whatever we are doing everything in the data frame in real time. But 80% of the questions, 80% of the questions in the interview would be asked by RD, in the RD. 80% of questions in interview. 80% of questions would be asked in the interview on RDD. But 100% we are using data frame in our work. So that's what you need to understand the RDD. Why? Because each and every, this is very basic and fundamental thing. That's why before going deep, I'm just giving you priorly. So each and everything, either it may be data frame, either it may be data set, anything. Okay, each and everything in Spark at backend stores in the form of RDD. Even though RDD expired in our work, but everything is converted into RDD and then stored in our on the top of Spark. That you need to remember. Even when you are working, like if you written data frame, if you are working on the data frames, you are doing everything, but at the back end, each data frame is converts into RDD and that RDD is stored in your Java virtual machines. That thing you need to understand. Okay. So we need to go deep dive into the RDD first. If you understand properly RDD, then we can move to the data frames. Data sets we are not using because these are implemented in Java and Scala. So we are not using Java or Scala. We are using Python, PySpark. That's why we are more focused into data frames. So, and one more thing, RDDs are used only for text files or log files. Used only for text files or log files. There, okay, text files or log. And data frames can be used for all types of data. All types of data. All types of data. What is nothing but all types of data? How many types of data we are having? Structured data. Structured data is nothing but table kind of data. Example is tables. Semi-structured data. Semi-structured data, which is nothing but, I can give you the example, is XML files or JSON files. XML or JSON. Third one is unstructured data. Unstructured data is nothing but videos, audios, social media. Some video, some audio, some text, like that. So data frame can be used by all types of data. RDD is only for text files or log. Just give me a second. I'll Yesterday we have seen all this. Today, what I want to do is, I just want to create a simple data frame, but it's okay if you don't understand also. But here in this, we have understand data frame, right? Data frame equals to df equals to any variable can be given here. Either it may be data frame or anything. But to better understanding, I'm giving df equals to what we are using spark dot. I just want to read one CSV file. Spark dot read dot spark dot read dot API, right? API is nothing but CSV. So here what I need to give, I need to give the path. Okay, I need to give the path. So I can explain you how many types of data frames we can create and all. But for time being, you just understand. I'll show you how to create one data frame. But if you don't understand also, don't worry. We'll slowly understand day by day. Okay. So df equals to spark.read.csv. Inside that, I need to give one file path. So this is a file store, right? Yesterday we have queried this. I'm taking one path from here. This one department. Okay, I'm copying this. We need to give the path. Need to the path. Just copied that and I'm giving path here in between the double quotes. Between the double quotes, I have given the path. And what I'm saying here is any CSV file, I need to give header equals to true. Because CSV files are having headers, that header equals to true, I need to give. Now I'm just, once the cluster is on, I'll create this. It will take 2 to 3 minutes. Before that, let me go into what is that? We are having notebook. And again, we are having, I'm just explaining you single mode, local mode cluster. Okay, this is a cluster. So what you are having inside the cluster, you are having Spark 4 API, which is master node, Spark 4 API, and finally you are having one executor. Just I'm explaining a single cell from this. Here what you are having, executor and one. So in between you are having resource manager, but I'm trying to give you single node. Suppose if you are having single node is nothing but only one node, only one worker node. How it works, it is not the multiple. This is nothing but local mode. So whatever you are doing in your community edition, that is local mode, because community edition itself is a source. Community edition itself is a target for you. Okay, single node one I'm explaining to understand. So here I need to give Spark 4 API. This is nothing but master node. This is the executor. Executor is nothing but Java virtual machine. Java virtual machine. So what the client is doing, client is sending data to the master node, which is job. Job is nothing but piece of code. Job is nothing but piece of. So what it is doing? It is doing Spark driver master node. What it is doing? It is dividing job to job to stages, stages to tasks. This is the main thing. So what is executor we are having? Java virtual machine. This is the local mode or single mode cluster. Mode cluster. What we are starting now? We are starting the cluster. Cluster is the compute, right? What it is having? It is having one master node, driver nodes, and each driver node and worker node. Worker node you are having catch and executor. Executor is nothing but Java virtual machine. This is the cluster. This is the cluster. That one I'm starting now. So inside the cluster, what I'm having master node, executor, and inside that what I will have, I'm having one resource manager also in between this master node and executor. So you can see here, if I'm starting the cluster, means I'm activating all these things. Okay, so inside the cluster, what I'm having, single node cluster. Single node is nothing but I'm having only one worker node, one master node. So from the master node to worker node, this mode is nothing but local mode. So all community editions of local mode systems. Those who are working on the community edition, it is nothing but you are working on the local mode. Local mode is nothing but you are having one master node and one slave node. So in the slave node, how many slots you will have? Two slots you will have. Two slots is nothing but how many processes you can do at a time? You can do two processes at a time. So what is having in the slave node? You are having in the slave node executor and catch. So what is executor is doing? Executor at backend, what it is there? Java virtual machine, JVMs. So this is what you need to understand. And so Databricks uses which resource manager? Databricks uses which resource manager? Databricks uses, okay, it is started now. It's trying to execute it. It has created the data frame. Now you can see data frame is created. Let me check what is the data inside the data frame. Okay, how to check this? We are having display function, display df. So see, this is the data you are having in here. This file. This is a path I have given. For this path, this is the data I'm having. This is displaying the data. Okay, so if I'm giving like this, df equals to spark.read.csv and the file path and header equals to true. What I'm doing? I'm giving that code to the master node. This master node will convert that into the number of tasks, stages to tasks. And after converting that in this executor, where is it? It is there inside. This is master node. In the driver node, that particular command I have given, that is executing in the Java virtual machine, and it is storing in the cache memory. I'm retrieving the data. So you are getting displayed here function. Just 2 more minutes. I'll wrap this session. I'll write brief notes. So which one? Databricks uses stand alone resource manager cluster or so one more thing you need to understand how is an in memory sorry wait. Let me come from the Spark is an in memory distributed processing engine. So how this works, how it stores in memory, how it stores memory is by using JVM. JVM is nothing but Java virtual machine, JVM, which stores the data in cache, stores the data. Okay, so what executor will do? Executor, where we are having this executor is nothing but Java virtual machine. Java executor is nothing but JVM. How JVM works? All processes, whatever you are doing, all processes in the all processes in the RAM, which is nothing but in memory. So all Java virtual machines, how many you are having, all those are working and processing the data by in the RAM. RAM is nothing but in memory. So Databricks uses standalone cluster. Databricks uses standalone cluster or resource manager. So Spark supports different types of resource managers. I'm just giving RMs, resource managers. One is Yarn. Second one is Mesos. Where we have used this? Have you remember? In HDFS, right? HDFS system. Or these two can be used in on-premises systems. What are on-premises systems? We can see that on-prem systems. Okay, next. It will give you standalone. Standalone also supported by Spark. By Databricks. And fourth resource manager is local, which is nothing but Databricks Community Edition. Databricks Community Edition. Next, fifth one is Kubernetes. Kubernetes by AWS. This one is supported by Spark. These are all RMs. RM is nothing but resource manager or cluster manager. Yarn Mesos is given to on-prem systems. Standalone is by Databricks. Local mode is your Databricks Community Edition. Kubernetes is for the AWS. Okay. Any queries? I'll wrap this session here. Tomorrow we can see all the database operations and we can see RDD. We can discuss tomorrow. So tomorrow it is completely into Community Edition. So you can see that. Any doubts? Till now?
No, Divya.
Can you hear me? How do you use the community edition? So I'm trying to create the workspace.
We have to use the which workspace?
For the community edition, I just sign in now, so don't know to find my way around it.
Still the question is unclear to me. So you are asking that it is about Databricks or something. Come again. Check.
Yeah, the community edition for Databricks.
Okay.
I just sign up now. So what any demo on how to use it or create workspace?
Okay, community edition workspace, how to use? That is what you are asking. Yeah. Perfect. You have already having this, right? So you are seeing your community edition blank because you don't have all these things. Okay. I have given some Python coding to Shanmukh, he will provide you. But if you want to work on something, you need to Sai, in which session I have explained, second or third. Have you remembered that?
No,
Next.
I don't have the video yet.
Yeah. It is there. You can go back and check the recording, but I'll give you in brief. So if you want to work on communication, what you need to do is just take a new notebook. Okay. So when you go to the new notebook, you will have your cluster to connect here. Just click on this and create new resource. Okay. Create new resource and create any like as such, like create and attach. Once it is attached, it is already existing. I need to give another name. So create and attach.
Second class.
What happens? You have reached the maximum number of, okay, it is already there. One cluster is on. That's why it's not, it is community edition. So you can't use two clusters at a time. But in your workspace where you are working, there you can have multiple clusters. You can use that. But in community edition, only one cluster is available. So you can on this cluster. Okay, you can on it, and after that you will start writing code here. And if you are writing in Python, you keep it as Python, or if you are writing in SQL, you can change it to SQL. Here you can change, or you can give it to here also percentage SQL, and it will change to SQL. Then you start writing the code. Once after writing the code, you need to do the execute run cell. Then you will get output here. Okay. And it is there already recorded. Shanmukh will provide you that recordings and you can go through it.
Okay, that's fine. Thank you.
Fine. Okay. Any queries? Okay. Thank you.